rover is the most refined rover today. It's meticulously designed, engineered, and crafted. Every single component, every process has been considered and measured to make sure of that. It is truly useful and it actually enhances its performance. This care, these considerations extends to how we ensure effortless mobility of the rover on different terrains. It is what led us to create the V.
Stability has always been a priority for the rover. This is to prevent it from toppling over and to protect the electrical component inside the chassis from disconnecting from the power source. The V is a suspension system that was exclusively designed so that the rover can have maximum stability by allowing each side of the suspension system to operate in opposite direction. This resulted in reducing the tip angle by 50% compared to common coil suspension. In addition, the angle between each of the suspension is designed to be as wide as possible, so we have a base area and a lower center of gravity, always providing a sufficient clearance for the rover.
The chassis of the rover is manufactured by using technology of 3D printing. The design of the rover is made up by different colors. This is to improve the aesthetic and make it more recognizable. Main reason a 3D printer is used is due to its high precision. A 3D printer can go up to 2 mm of precision, which is exactly what we use for the rover. With only 25% density, it is light yet strong enough to sustain the stress and hold up the whole rover. All electronics are securely stored inside the chassis. The design is so effortless and simple. We believe all the determinations we put in the rover design make it a distinguished product.
We decided to go big with the wheels. With a 15 cm diameter, it's larger as compared to all the other teams. We also decided to use 3D printing as a method of forming the wheels out. 3D printing allows a very accurate calibration and it ensures the wheels are intact. Uses polymer as a method of forming the wheels. Besides being lightweight, polymer has also very low corrosion rate from the friction between the terrain and the wheels, making it an ideal material as a wheel design. Thick 1 cm threads are used to sink the wheels deep enough into the terrain to produce more backward forces to push the rover over an obstacle.
Lunar rover, DC motors are used in accordance to the mode of steering of the rover, which is skid steering. The motors chosen are of high torque and low RPM, as speed is not an important factor. Rather, the torque is needed to climb over obstacles. Based on calculations online, to climb over obstacles, 1.5 Nm of torque per motor is needed. Therefore, a 12-volt LiPo battery is used for the motors and the motor shield.
Arduino Uno is used to create the entire collision avoidance system and to power the motors of the rover. The collision avoidance system consists of 3 infrared sensors placed in optimum locations, mainly 2 in the front and 1 in the rear, for maximum detection. The rover is able to not only detect but also avoid the obstacles blocking its path. Our programmers have worked very efficiently to create a unique way of coding to cater to the design of the large wheels. The coding is done so that when the sensors detect an obstacle, The rover reverses before changing to the opposite direction before continuing forward again to avoid the wheels to come into contact with the obstacles.